All right, hello everyone. Last time we were doing this simple problem. Um, Now we're moving on. That's kind of like review for this thing. No, we're gonna move on to this thing, and we're gonna go back to that fraction thing later because fractions. I don't know why, but if I'm not correct, we learned that later again. Just a little bit of faster form. Over here, we're just gonna say that we're gonna start off with basic things, and we're going to learn zero. If you multiply something by zero equals zero, therefore nothing happens with that, and then you can figure out the rest. Over here, we're going to learn. We're going to put again. This is human made. Human made. No one actually discovered the concept of minus subtraction addition. Human made it. So what I mean by that is that if no one taught you this, there's no way you would know this because humans made it. It isn't made by some, law. It's made by humans. All these symbols, 20 is symbolizing 20 things that's made by humans. Um, but what I'm looking for in here is basically their knowledge of subtracting both sides from something equal. Again, you have to teach them this because this is human ideas going to one person to another to communicate. So this is communication. Math, all math is basically a form of communication. No matter what you say, that is facts. Like that's literally the facts of math. So here, minus 20 by both sides. I want them to write the answer for x, which is negative. But negative number is also really confusing to little kids because how in the real world would there be a negative number? Impossible. Impossible. And that's what humans have thought of because it's kind of impossible in real life. But in algebra, it is possible. In mathematics, it's possible. And in certain points, in physics, it's possible because if you think about it, there's a direction, and negative represents the negative going down or up depending on which way is positive, which was negative. I might do a physics question later on just to prove it. Because physics is fun, you know that, right? Um, anyway, negative numbers are possible here, and that's the reason. And negative multiplied by negative equals a positive. That all needs to be taught. They don't know it intuitively, and the reason we know negative multiplied by negative is a positive, there's multiple ways you can explain that to him, but most people just memorize it. But you could also explain it to physics terminology. In physics, because if you prove it in physics, oh, that's real life, right? So you can actually prove it in there, or you can prove it with other ways to in mathematical terms, like that just makes more sense. Or your choice, not mine. Uh, anyway, what this is here for is just to figure out negative numbers. Seriously, that's all. Um, you'll need to explain it to the kids before you give them this because otherwise they're dead meat. They should never get this right, unless they read ahead, which is dumb because teacher because there's no benefit to doing that. I don't understand why would they do that. I mean, you could. There's no benefit, although. Anyways, over here, just learning just that just to cancel out. Now this is just algebra, cancel out. That's all I'm looking for there. Um, Over here is basically looking for ability subtraction in different variables, and you have to teach them this because no one is intuitively in tune to know that you can subtract this. There's no way unless they read ahead or they already have prior knowledge from their parents or something. Um, Also, that's why graphs it should never be intuitive. Um, you have to teach them it. That's fact. But we're not going in there. We're going to go to the basics. Here's the basics. And what else is there to know? There's a lot, but that's the basics of what this part is. Let's see what time this thing is on. 4 minutes. That's fine. All right, let's go to the next question then. Okay, next question probably would be on the lines of negative multiplication and division. So let's just say x squared 2. How do I do this? There's a way to make it so that. Wait a second. Okay, so um, Oh, we'll just go do multiply by x equal. That does look really bad. Wait a second. So here we're gonna say x multiply x equal x2. That's the basics to the power something. We're also gonna say different symbols that basically used everywhere. X is used everywhere. Y is used everywhere, and Z is definitely used. And then another one we use is A, B, and C. D, E, F, and blah blah blah, all the different variables. Fine. This is very much not a real question. This is just basically a fact and matter, and just so you know. So what needs to be taught here probably is something on the lines of what happens if you kind of have a parentheses in there. We get something like that. Okay, so like like 2 plus 2 parentheses x minus 2 whatever minus 1 equal 1. Um, well, what you need to know is multiplication and how to multiply the distributed property of it. So no one knows this because no, the people that knows this is only the people that are exposed to it because, again, humans made this. Mathematics is just a communication of language, another type of language. It's basically another language art. Um, and these symbols are like just words on formulaic form. So think of it like English, kind of. Um, kind of weird to say that because I'm not the best English person until like very recently. But that's how mathematics works. Huh. And people that says otherwise, their choice. I'm not the one that's forcing them. And I'm gonna say explain because it's also. But how would you explain this? Is like you have to teach them this. Like no one is known gifted with substance multiply across like the substitution no the well, yeah, no one's known that. It's communication from others. So someone has to teach them it so that they can apply it. So just figure out the answer, and if they figure out the answer, who cares what method they use? They know how to do it. I think I'm gonna just make it simple and just do that. Um, because as you can see, if that happens, it's also a negative number. So good. So what else do they need to know? Well, they don't need convergent factors yet. That's later on. So this is just the basics. Now what should be done is probably the fractions and how you denote multiplication division. To be fair, writing this thing over here, let me get a pen. Um, Later on, you probably don't even need to use it because you'll use parentheses a lot more. So you may want to teach the kids if you are a teacher. I am not a teacher. I'm just a person that has done. I don't know. Love this. Love making questions. So here's me doing it online. I'm like a little bit of a nut job. Good joke. Anyway, so you might want to get them down. So that way is possible. What else do you need here? Well, I think division is necessary. To know why am I doing this also? It's just because, well, why not? You probably need to explain this beforehand, or they won't know what they're talking about or what you're doing, and probably you wouldn't use this at a. So, but what would you do next after this? What kind of questions you can give? You probably give a division problem now, just because there wasn't any division problems. The way we learn division in basic terminology is two ways. One way is the memorization thing, If you didn't remember long division, that's the way we did it and get all the points. Actually, sorry, I take that back. There's three ways to learn this. But the third way is like everyone has to learn it because you have to know that in the future and convert that into that final form. So we'll just watch this and you'll know. I'm pretty sure you'll know. So what I'm gonna do equal, and I'm gonna do, well, yeah, 3 divided by 5 was an awful one to choose, then wasn't it? Oh well. Let me. Yeah, it was an awful one. Anyways, 3 divided by 5. There's three ways to learn it. I forgot the last way. Let me think. There's one more way. I don't know. All right. So this way is just going and doing it, and this one obviously you have to go 0 point something something something. And we need. There's also a remainder form you have to learn because even for now it's not important, but when you get to certain calculus problems, you actually do use it. And if you go to certain problems, you do use the actual remainder thing. So if you have R, put R there sometimes just to make sure they know how to solve both ways. Um, so this one I would not do 5 divided by 3 because that would be inappropriate use of certain you know, it would be just dumb. So I would do, first of all, let me get that thing up over there. Actually, how much time is there? Okay, that's enough time. All right. Go over here, put R in there. So this one doesn't have R because you want to go division. And if you divide that, well, it's 0.6 if I'm not correct. So, but the third way is an interesting one because I think I should get better numbers for this. All right, let's just do 6 divided by 10. Well, you wouldn't so normally you wouldn't consider this a division form in this most basic sense because it's not in this most basic sense. Um, what I mean by this is I want to turn that into a fraction, which in later on that's literally how you answer things later on. So it might not look like an answer. That's the third way. Um, but later on, that way is like the way you would use it a lot, other than the five, other than the top one and the second one. So what I mean by that is turn this into a fraction. Um, does not feel like solving at the time period, and simplify. But technically speaking, it is a way of solving. Um, because that's how a lot of people just leave the answer because it's kind of like 0.3333 who has the time to do that, like one third is better, and sometimes like 125 divided by 165, who has the time to actually do that, so leave it as a fraction and simplify. Sometimes they don't even simplify it because it's so long. So sometimes it's valid to just give a fraction number, and when you give this kind of question, they don't realize it that this is going to be like an answer later on in the future. It's like a valid way to divide, but it is technically speaking, and they're they probably won't know it until like very later on. But that's a valid speaking method for division. Technically speaking, yes, it is. So for the remainder thing, I'm gonna give a problem. And if you're thinking, oh wait, shouldn't you just give a long problem? And that's actually two. So let's just give them a like. All right, let's just do 7 and 8 there. I don't think that'll take that long. It's long division, and maybe it will. It's just a new. If they're new at this, right? So maybe that's good enough actually. All right, let's go for this one. Um, 30 divided by 2. That's horrible. Let's just do 31. That should do the trick. That's still horrible, but works out my favor. Let me get this up and running. And that does. Oh, what happened there? That's not what I wanted. Because that would be that would be wrong. I mean, you could solve that, I guess. Yeah, you can do it. I just don't want that because, well, why would it? uh, it doesn't really matter which one you choose. So that's the two ways I can think of that you can solve a division problem. Three ways, technically three, but for now they probably teach it in class. Like there's these are the two things that you can solve the division problem, and you might want to explain to them that they're both going to be used in advanced math. Just that one, the division with the remainder might not be used until like calculus, because I believe that's when you use that. Um, I guess a little bit, but you know what I mean, right? And for the first way to solve it, you'll use that a lot because yeah. And then the third way you probably use the most thinking about it because well, I mean later on you use that a lot just to solve things. Like who doesn't like a simple problem where they have a fraction and you get 3 divided by 5? That's 3 divided by 5, and just leave it as that. No one would divide it and get a decimal. I mean, they could, but it's the same answer. So is that all for this section? Probably. I mean, I think it's good to have it later on go to word problem, but we're just doing pre-algebra. If you ask me, this is not something that they have, So, I think it's good enough. Unfortunately, the time hasn't up yet, but I did make questions, and I think there's one thing that I've missed so far, and that is to excuse me. There's one thing I missed. Let me just copy this and paste it. So, yeah, this is going to be plus 2. No, plus x, sorry. And that one is also. So, what I'm putting here is the basic things you can make question out of. You can make this into this, that, but yeah, I guess you can clearly see that. But what you don't want to do is do something like a square with combine these two, like combine this and this. That will make it so much confusing, and they probably don't know square roots yet. Um, if they do, well, good for them. But pretty sure they don't yet. So I did this just to give valid question argument for this one, but you have to teach each and every one of them, or it won't make sense to them. Again, math is a language, and there's some people that know that language more, and some people that don't know the language a lot, less. And if they don't know the language, it's impossible for them to learn it, because how would you? So if I want to give a question about x, what is x with the x? I don't know, x equal 125. That's a perfectly valid question, but can they solve it? No, they can't. So that will not fly. You can't give that question because they can't solve it. But if you gave x with the 5 with another 5, 5 equal 125, well, certainly turn to a valid question, right? And then if you said, well, what is x? Let me give you a top. Equal question. Let me do a question. Sorry, but if you do this, and probably differentiate. If you do, let me get the pen. If you put a 3 up here, oh, wait a second. It suddenly turns a valid question. Since this concept works, and you're not actually talking about roots yet, because you shouldn't be teaching it yet, because students will never know it because they haven't been exposed to that language yet. There's no way they will know it unless they're pre-exposed again. And how would they explain it then? They'll say x equals 5, and by the rule over given over there, given over here, so they would just, I don't know, the power, not the power, say that x multiplied and 5 multiplied by 5 multiplied by 5 equals 125. And since they figured it out with division, because division is something you taught them, hopefully. If you didn't taught them, you had to teach them later. Um, this is possible. Um, or they could just give the answer and you say, oh, that's good. Full credit. If they get the answer right, there's no need for them to explain it because at this basic level, they'll probably know what they're talking about if they get it right, because that's how this process works. So that's a valid question. So, what's another valid question I could give? Well, another valid question for this timing. Later on, this valid question will grow, but for now, we're trying to restrict it because there's not a lot they learned yet. So the questions I can give has to be valid to the things they learned. So this part, if I had to do something, 2x right, or 2x right, but this is my opinion. I'm just a crazy person that loves making questions and makes a lot of painful choices because I'm dumb sometimes. Um, let's just say, okay, so if I do 3x, where's x, equals a plus b, that's not valid. Um, oh, sorry, that's not valid. Yeah, what is valid is for you to follow that method over there. You're not It's not valid to do 2b. It's valid to do 2b, right? 2x, right? It is valid. Why? No, it's not valid. Sorry, you have to do x again. This is valid because you have taught them this. Therefore, doing this is valid. If yeah, that's valid. Yeah. So I'm just showing you more valid moves. But what else can I do with this later on? Because that's, that's not simple for them. That's actually really hard. But you can't figure out x, right? That's impossible. You can put all x's in, and that's not valid. So what I'm gonna do here is do what? Sorry. Do put a number here. No. That equals 0, right? That's infinite solutions. That won't work for this question because you have a set rule here. You can't do that. So that's not valid. Sorry. So you have to give something like 3 here, 15 here to make it valid. Or, sorry, or make x equal 3 to make it valid. Well, I meant to say this is not valid. You can't give this question because there's infinite number of solutions. Sorry, my mind has been fried. So I would just give him 3, and that's considered a valid question, and that would work. Infinite number of solutions they should not learn yet. So know those. That's what I meant to say. I made a mistake. Saying my words were fumbling earlier. Haha. Amy, is that good enough? Let's see what the time is. I guess that's good enough, but I think one more questions can be added. But I won't. I think this is good enough for the basics of everything. Um, so, yeah. So no weird shenanigans, just the basic. All of this is on the description below. Like you can go to page 3, they'll write page 3 there, and then here is it here, or you can go to page 2 for this thing, and page 3 you can go over here and download this PDF and literally just print it out. This was a little weird, so I'm gonna fix it a little bit. But this is definitely not for just learner. So this is something that should go way in the back and should be hidden away until later on. So yeah, so, you know what? I'll put them in the back right now. So understood. I think it's time to cover end it. Let me end it right now.